Welcome to the second part of our tutorial on 3D. In our last tutorial, we learned a lot about the market. When we go to a video store to rent a three-dimensional film, then we will determine in a good scenario that 90% of the film feature does not correspond to the basic laws of stereoscopy. That means that they were artificially generated on the computer, meaning that they were pivoted two-dimensionally and then converted into three-dimension. This results in an unnatural optical perception on the part of the viewer, as he does not know what is wrong with the visual images he is seeing. In any case, there are no natural parallel axes that are being assimilated. There are in fact only 10 films that have actually been filmed, cut and presented according to a stereoscopical point of view. These films are of course a pleasure to watch. However, we first of all want to determine what the laws of stereoscopy entail. It utilizes the camera to imitate the movement of our eyes. There are two types of muscle movement that are at work in our eyes. First, there is the side movement of both eyeballs. Our eyes are spaced at an average of 6.3 centimeters from each other. However, with some eyes, this difference can be greater or smaller. The side movement of our eyes is called convergence. Our eyes don't see on a parallel plane. The particular object that we focus on is not viewed through a parallel line of sight, but through parallel axes. In other words, they cross at a certain point. We always move these parallel axes every time we focus our view on a new object. Automatically, that is to say, we don't notice that we're doing this. The second movement, parallel to convergence, is the focus. It also moves and adjusts itself automatically on its new object of vision. We're not even aware of this. There is a possibility that both muscle movements can be decoupled, which can result in bizarre effects such as the magic eye, which was a great literary success in the 80s. There are people who may not be aware of these books, but for those of you who have enjoyed them, you can appreciate what I mean. In order to better explain the movement of the muscles in our eyes and their function, let us first of all conduct an experiment together. First of all, close your right eye and lift up your left thumb. Now take that left thumb and hold it up to an object in your home, which is somewhere far away from you. It can be a door, a window, or in my case, a curtain. I'm lifting my thumb up to the curtain and now I'm going to switch eyes. That is, I'm now going to close my left eye. If I really concentrate on my thumb, I'll now see how the curtain in the background jumps to the right and then back again.
Rechte Auge zu habe. Ja, daran sehen Sie, dass unsere Augen sich
Through this experiment, you can see that our parallel axes cross over where the area on the middle of the thumb is and behind the curtain in order to visually move the corresponding part of the curtain. Now we're going to conduct the same experiment, but this time we're going to focus our attention on the curtain.
Okay. So. Und machen dasselbe Experiment. Was passiert?
What happens? This time our thumb jumps to the left. How can that happen? First of all, the curtain springs to the right. Another time, the thumb springs to the left. The following has occurred. When we look at the curtain, our focus is on the curtain and the thumb is at the crossover point of the parallel axes. For that reason, the thumb jumps to the left. However, if we look at our thumbs, the curtain will spring to the right as the parallel axes cross over the thumb.
Parallaxe sich an dem jeweiligen Objekt kreuzt. Ich will Ihnen das mal zeigen, schematisch, was unsere Augen.
I'm going to show you schematically what our eyes have to do and process without us noticing it.
Das hier sind also unsere Augen.
These are our eyes.
Und das hier ist unser Daumen und ganz hier hinten ist der Vorhang.
And this is our thumb, and right behind me is the curtain.
So, jetzt passiert Folgendes. Wenn wir zuerst auf den
Now the following will occur. When we look at the thumb, then we'll see that the parallel axes cross exactly over the thumb. So whatever is in front of the thumb will jump to the right, though at the moment there is nothing in front of it. Whatever is behind the thumb, such as the curtains, will jump to the right. Now let's look at the curtains and we'll see that the thumb is clearly in front of it. The thumb will now jump in the opposite direction to the curtain. Depending on where our focus is where we will find our pictorial plane, and in the following tutorial we will call this plane key. Everything that is in front of the key is defined in our brains as foreground. Everything that is behind the key is defined as background. The key is also simultaneously the pictorial plane with 3D pictures. This means that what is considered to be the key on a 3D picture is the edge of your television. When you're watching a 3D film at home, for example, then you have your actual screen as your real pictorial plane. The virtual picture pushes itself into the wall and sticks out of the screen. The key, the point of intersection of the parallel axes, is also always the pictorial plane. In order that one can determine in photography how far objects need to stick out of the picture, or on the other hand, how far they need to be pushed into the picture. Purists among 3D photographers say that one shouldn't allow anything to protrude out of the picture, and that everything behind the synthetic pictorial image should be banned behind a synthetic platform. I don't advocate this notion. I personally like it when objects stick out a bit from the picture. However, this is every individual's artistic discretion. Thank you for watching, and we hope to see you in the next tutorial.